Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. Friends, GATE 2023 examination is over and you have got the response sheet also from the IIT Kanpur official website. Now, this is our responsibility that we must provide you the correct and the most authentic solution for each and every question. Ashutosh Sir has also taken some of the session for electrical and electronics, and he has solved many questions which were either quite misunderstood or little bit not that much direct, and there were some misunderstanding about those questions. So I hope you enjoyed the session by Ashutosh Sir. I will be discussing one question from power system, and this is one of the classical question in the recent years which we have seen in the GATE examination. Even though its solution already I have presented, but I want to modify it, and it is required for all the future aspirants also if they want to have a better command over the technical portion. So let us first understand the question and let us see how this MSQ question, this was the MSQ question, how this MSQ question is going to be one of the most classical question for power system in the recent years. And this was the first time, let me just tell you, this was the first time, and it was a 2-marker question. It was a 2 marks question. And this was the first time in the electrical category we have seen the MSQ questions. So definitely for all the future aspirants, it is important that you take significant care about the MSQ questions. Let us read the question carefully. See what the question is saying. Question is saying that there is a bus admittance matrix is given. So this is the Y bus. The elements of the Y bus are mentioned. Now he is asking, consider that there is no shunt inductor connected to any of the buses. This is one of the input statement given. Now he is asking which of the following can not be true. So you have to find the incorrect statements or the incorrect options you have to mark as your answers. So let us first understand. Suppose it is a 3-bus system and it is something like this. I am taking the most general case. These are the 3 buses, bus number 1, bus number 2, and this is bus number 3. Now in the question, the statements are trying to search or trying to find whether line charging capacitance is present in different lines or not, and whether shunt elements are present or not. So before I start drawing the final general network, I want to give you some understanding about what is the difference between the line charging capacitance and the shunt capacitance. Let us take one simple example. Suppose we have a 2-bus power system. Suppose we have a 2-bus power system. I am not making it complex, so I am not introducing the transformers, please understand. And suppose there is a load. Suppose there is a load. This is bus number 1 and this is bus number 2. And this is a transmission line. It is a general transmission line. Now, if I want to represent this transmission line, for example, as a medium transmission line, so there are 2 possibilities. Either I can represent it like a nominal T model, or I can represent it as a nominal pi model. But generally we go for nominal pi model, because if you go for nominal T model, unnecessarily an extra node is going to be created, which will make your system even more complex in terms of calculation. So if you go by the nominal pi model, how we represent our transmission line? We represent our transmission line like this. This is Y by 2 and this is Y by 2. Now the capacitance within this Y is going to be the line charging capacitance. But there may be one shunt element connected here also. Yes or no? Now this may be a capacitor, this may be an inductor in general, but any shunt element may also be present. So when we talk about the line charging capacitance, we are trying to represent the line charging phenomena in the transmission line. What is this line charging phenomena? It is a kind of leakage current. In the most simple word you can understand, if a current IS is sent from the sending end, some amount of this current, suppose it is IC1 and this is IC2 and this is the receiving end current IR. It means the current which is sent from the sending end, because this IC1 and IC2, it was actually sent from the sending end, but it is not reaching the receiving end. Somewhere in between it is lost. How? Because of the line charging phenomena. So it's like a leakage current, you can understand in most simple way. So this phenomena is represented by these line charging capacitances, whereas the shunt element concept is completely different. It may be a capacitor, it may be a inductor. So this is the understanding about line charging and shunt element. Let us come back to the question. Now first we are assuming the most general case. Suppose the shunt element is connected to all the three buses. Suppose the shunt element is connected to all the three buses, something like this. This is suppose Y10, this is Y30, this is Y20, and suppose here the line admittance is going to be Y12, this is Y23, this is Y31, and suppose I am assuming this, that the line charging capacitance is present in all the three sections of the line, 1 to 2, 2 to 3 and 3 to 1. So line charging has to be capacitance only, yes or no? So I am directly putting the capacitance using the nominal pi model. I hope you are able to follow me in this. So this is going to be Y charging 1 to 2 divided by 2, because half of the admittance we have to distribute on both the ends, and this is going to be Y charging 1 to 2 section of the line divided by 2. This is going to be Y charging 2 to 3 divided by 2. This is going to be Y charging 2 to 3 divided by 2. This is going to be Y charging 3 to 1 divided by 2. This is going to be Y charging 3 to 1 divided by 2. So this is the most general case we are getting for a 3-bus system, which may be one possibility. Now I am trying to make the expressions for the diagonal and off diagonal elements, and I will check what are the conditions we are getting. So first I will go for the off diagonal elements because they are quite easy to relate. So what is going to be Y12? This is same as Y21, so this is going to be minus of Y12. Y12 or Y21 is given as J10. So it becomes J10. So you can write as Y12 or Y21 is small is minus J10. Is minus J10. Yes or no? Is minus J10. Similarly, you can write after Y12, you can write Y13. So Y13, Y31 is equal to minus of Y31, and that is given as J5. So you can put it J5, and finally you can write Y31 or Y13 as minus of J5. Similarly, you can write Y23 or Y32, which is given as Y23 is J4 or Y32 is same. They are symmetrical. So J4, Y23, sorry, Y31 is J4. So you can write it as Y31 or Y13 as minus of J4. I hope it is clear. So this is for the off diagonal elements. All the off diagonal elements we have covered. Now we will go for the diagonal elements. If you go for the diagonal elements, the diagonal element is going to be how much? For bus number 1, it is going to be all the branch admittances, branch or whatever admittances directly connected to bus number 1. So Y12, Y10, Y12, Y31, Y charging 31 by 2, Y charging 12 by 2. So Y11 is going to be Y10 plus Y charging 12 divided by 2 plus Y charging 31 divided by 2 plus it is going to be Y12 and Y31. It is Y12 plus Y31, and this is given as Y11 is given as minus J15. It is minus of J15. Now you put the values. So what is Y1 naught? What is Y1 naught? No information. So let's write it like this. Plus Y charging 1 to 2 divided by 2. No information. Y charging 3 to 1 divided by 2. What is Y12? What is Y12? It is minus J10. It is minus J10. What is Y31? Y31 is minus J5. So this is minus J5. This is minus J5. 15. So this is going to be cancelled. So finally for Y11 you are getting the equation that Y10 plus Y charging 12 divided by 2 plus Y charging 31 divided by 2 is equal to 0. Now I am 100% sure that this is going to be a capacitance because it is line charging, we have assumed it. This is also going to be a capacitance. Now, if the summation of this shunt element at the bus number 1 plus capacitance value, admittance of the capacitance, line charging capacitance, if it has to be 0, then there is only one possibility that this Y1 naught has to be an inductor. Yes or no? If it is a reactor, then it can compensate these two line charging capacitance. But in the question, it is clearly mentioned that no shunt inductor is connected to any of the bus. It means there is no possibility that this equation will hold. So this equation will not hold means what? That Y10 is going to be 0. That is the only possibility. And these two line chargings has to be 0. Y charging 12, Y charging 12 divided by 2 is 0 and Y charging 31 divided by 2 is 0. This is the only possibility because this is also capacitance, this is also capacitance, this is also capacitance. So 3 capacitive admittances added together can only be 0 if all of them are 0. That is the only possibility. Because suppose 2, 3, 5 cannot be 0. 3 things cannot be equal to 0. So this has to be 0, this has to be 0, this has to be 0 because nothing can be negative. So the only possibility is 0 plus 0 plus 0 is 0. So this is one conclusion we have got. Now let us go for the Y22, that is the diagonal element for the second bus. So this is going to be how much? Y22 is going to be Y2 naught. It is Y2 naught plus Y charging 12 divided by 2 plus Y charging 23 divided by 2. You can correlate with the diagram plus Y21 plus it is Y23 and this is given as Y22 is given as minus J13.5. This is minus J13.5. Again, you don't have any information about Y2 naught, so take it as it is. And this is Y charging 1 to 2 divided by 2 plus Y charging 2 to 3 divided by 2. Now, what is Y21? Y21 is minus J10. This is minus J10. What is Y23? Y23, okay. I think I have done something wrong. Y23, yes, it has to be Y23 now. Please correct it. It has to be Y23 and this has to be Y23 or Y32. Now it is correct. So what is Y23? Minus J4 plus minus of J4 and this is minus J13.5. Minus J13.5. If you solve this, you will get Y2 naught plus Y charging 1 to 2 by 2 plus Y charging 2 to 3 divided by 2 and this will come out as J0.5. J0.5. Now this can be one possibility because this is capacitance, because no shunt element is going to be a reactor. So this is capacitance, this is capacitance, this is capacitance. Now x plus y plus z equal to 0.5. It has infinite solutions. You understand this? It has infinite solutions. So let us call it equation number 1. I'm just writing it like this. And let us check for y33. What is going to be y33? y3 naught plus y charging 31 divided by 2 plus y charging 32 divided by 2 plus y31 plus y32. Just put the values. What is y33? y33 is given as minus j8. So this is minus j8. y3 naught, no information, write it as it is. Y charging 31 divided by 2 plus y charging 32 divided by 2. What is y31? y31 is minus j5. This is plus minus j5 plus what is y32? y32 is minus j4. So this is minus of j4 and this is minus j8. So if you simplify this, you will get y30 plus y charging 31 divided by 2 plus y charging 23 divided by 2, and this will come out as j1. Now again, it is going to be capacitance. This is also capacitance because it cannot be a reactor if it is there. Y charging 31 also capacitor. This is also capacitor, and this equal to 1. It means x plus y plus z is equal to 1. So again, there can be infinite number of possibilities. Suppose this is equation number 2. Now let us go back to the statements and cross check. Let us start with, I am leaving statement 1 because this is one of the controversial one. I will start with B and I will later on come to A. So statement B is saying line charging capacitance of the finite value present in line 2, 3. But he is writing only. So only we have to check. But before that, let me just finally make the possibilities. One final network so that we can discuss the possibilities. So this is a 3-bus system that we have taken. Okay. So this is bus number 1, this is bus number 2, this is bus number 3. Now if I come to this conclusion, yes, this was the conclusion. This is 100% correct. Y1 naught has to be 0. This is 100% correct. Y1 naught has to be 0. This is 100%, because there cannot be any other possibility. Are you getting this? This is capacitance, it cannot be reactance. This is capacitance, So C1, C2, C3 can be equal to 0 only if C1 0, C2 0, C3 0, because nothing can be negative, yes or no? So this is 100% sure. And this is also 100% sure. Individually they are 100% correct. So bus number 1, there is no shunt element. Okay. Let us come to equation number 2. Equation number 1. Equation number 1 is saying y2 naught, y charging 1 to 2 by 2, y charging 2 to 3 by 2 and j 0.5. Now here we have got that y charging 1 to 2 is 0. Y charging 1 to 2 is 0. So if y charging 1 to 2 is 0, what does it mean? Y charging 1 to 2 is 0, what does it mean? It means y2 naught plus y charging 2 to 3 divided by 2, and this is equal to j 0.5. Because 1 to 2 is 0. We have already concluded it, 100% sure. Now y2 naught may be 0. Please try to understand this. There is a possibility, suppose y2 naught is 0 and y charging 2, 3 by 2 is j 0.5. So this can be correct. Again, there is a possibility that y2 naught is J 0.5 and Y charging 2, 3 may be 0. This is also one possibility. Are you getting this or not? Please try to understand. I'm repeating it. This is most classical question we have seen for last couple of years. This may be 0. This may be J 0.5. This may be 0. This may be J 0.5. It means I'm writing it here so that you don't confuse. Bus number 2, shunt capacitor, because reactor is not possible, may or may not be present, because there are infinite solutions to this. Now, Y charging 2 to 3 may be present, may not be present. Very important thing I am discussing here. May be present, may not be present. So, I can say line charging capacitance may or may not be present in line 2 to 3. Please understand this. Line 2 to 3 may be present, may not be present. Both the possibilities are there. This is the beauty of this question. So we have got two conclusions. Are you getting this? Now let us go back to the statements. So now you can start with statement B. He is saying, sir, line charging capacitor of finite value present in line 2, 3 only. This is wrong. May be present, may not be present. So read the second part of the statement. And shunt capacitor of finite value is present in bus 1 only. This is 100% wrong. So B is wrong. So if B is wrong, because you have to choose the incorrect one, na? B is wrong. Let us read the statement 3. It says line charging capacitor present in all 3 lines. This is also a case of possibility. May be present, may not be present. So this is also wrong. Line charging capacitor of finite value present in line 2, 3 only. Incorrect. May be present, may not be present. And shunt capacitor of finite value present in bus 3 only. So this is also incorrect. Let us come back to statement A. It is saying line charging capacitor of finite value present in line 2, 3 only. This is also incorrect. Because that is the case of a possibility. Are you getting this or not? Yes or no? So as per the analysis, you can see all A, B, C and D you have to mark as correct answer, because all the statements given, they are incorrect. And this is because of this word only. If they have written in terms of possibility, there might be a possibility that may be correct. I hope you are getting this now. So this understanding will give you that how to do this question finally. And there is no need to go for this. For example, this also if you apply, because this is 0. So you are getting Y3 naught plus Y charging 2 to 3 by 2 is equal to J1. Now there can be infinite number of possibilities here. This is 0, this is J1. This is 0, this is J1. So you cannot be 100% sure where shunt element is present or not, because there can be infinite possibilities, infinite networks you may draw for these conditions. So I hope you understand this question. So all the future aspirants, be ready for more MSQ questions, and there is a high possibility that next year also in GATE 2024 you will be getting good number of, I just expect that 8 to 12 questions you may expect, even 15, up to 15 also there is a possibility for MSQ questions, because we have seen generally when the MSQ questions are introduced, their numbers are slowly increasing. So subscribe to BYJU'S Exam Prep for all these important updates. Thank you so much. Thank you.